Today we are going to discuss second chapter of your syllabus, polynomials. You have seen many algebraic expressions. Let's consider a situation where you are calculating the perimeter of a square PQRS of 3 units. How do you calculate the perimeter of a square? Perimeter is equal to 4 into the length of the square, or sum of the all 4 sides, which is 4 into the one length. Okay, 3. Then it is 12 units. Let's consider another square. This is ABCD. This is of 4 units. Then how do you calculate the perimeter? Perimeter is equal to 4 into 4, which is 16 units. Here we can see that 4 is constant in both the expressions, in both the calculations. Here 4 and here 3 and here 4 and then 4. That is, the first term is constant, the second term keeps on varying. So we'll take this as a variable and consider this as a variable and this as a constant, and we can say that the perimeter of a square can be calculated by the expression is equal to 4x units, where x is 1, 2, 3 and so on, based on the length of the square. This expression is called as algebraic expression, or also called as polynomial. Let's see what is a polynomial. 2x square plus 3x plus 1. This is polynomial of variable x. 2x square, 3x and 1 are called as terms. These are called terms. 2x square is a term, 3x is a term, 1 is a term of the polynomial. Here coefficients are, what's the coefficient of x square? The coefficient of x square is 2. The coefficient of x is 3. And what is coefficient of x bar 0? See, here we have x square, the next term is x, the next term is x bar 0. The degree or the power goes on decreasing, 2, 1 and then 0. The coefficient of x bar 0 is 1. Do you know what's the coefficient of 2? 2 is also a polynomial. It is called as constant polynomial. This is of coefficient x bar 0. Minus 5 is also a polynomial. This is constant polynomial. You can take any number, 3 by 4, 6, 325, 325, all these are constant polynomials. 0 is also a polynomial. This is called 0 polynomial. Then we have told 2 is a coefficient of x bar 0. Then what's the degree of this polynomial? This is of degree 0. And we have taken an example, 2x bar 3 plus 3x plus 1. Here the degree is power or the exponent. of the variable. So here the variable is x bar 3. So the coefficient of x bar 3 is 2 and the degree of x is 3. Here the coefficient of x is 3 and the degree is 1. Here x bar 0 exists. Here the coefficient of x bar 0 is 1 and the degree is 0. For a constant polynomial, the degree is 0, and for the 0 polynomial, the degree is undefined. The degree of 0 polynomial is undefined. Let's consider the polynomial in variable x. How do we represent a polynomial as? We are writing a polynomial in variable x. It can be represented in the form of p of x or g of x. Whichever name you want to give, you can give. P of x. Let's say x bar 4 plus 5x bar 3 plus 6x plus 1. This is a polynomial. Here we can note that the coefficient of x square is not there. X square term is not there. We can consider this polynomial has x bar 4 plus 5x bar 3 plus 0 into x bar 2 plus 6x plus 1. Let's see how many terms we have in this polynomial. 1, 2, 3, 4. We have 4 terms in this polynomial. Let's consider one more polynomial, p of y. This is a polynomial in variable y. Y bar 5. This is also a polynomial. Here how many terms we have? We have 1 term. So this is called as monomial. If we have 2 terms, say p of y is equal to 5 y bar 3 plus 1. We have 2 terms here, so this is called as binomial. And which has more terms, it is called as polynomial. The polynomial having 1 term is called monomial. The polynomial having 2 terms is called binomial, and a polynomial having 3 terms is called a trinomial. X plus 1 by x. Let's find out is this is polynomial or not. This can be represented in the form of x plus x bar minus 1. Here the power is 1. When the denominator term will come to the numerator, then the sign changes. Here let's see the degree of the polynomial. The degree of the polynomial here is 1. The second term has minus 1. This is not a whole number. Therefore, this expression or this is not polynomial. This algebraic equation or the expression is not a polynomial. Or we can say root x plus 1 by root x. This is also not a polynomial. A polynomial can be represented in the form of, let's say, x bar 150. This is one term. The next would be x bar 149 plus x bar 148 plus so on plus x square plus x plus 1. This is polynomial of variable x. See how many terms it contains? It contains 151 terms. This is of the degree 150 and here the value is plus 1, that is 1. So this from here till here is 150 terms, plus 1 is 151. Let's see what is degree of polynomial. Degree of the polynomial. Let's consider a polynomial x power 15 plus x power 14 plus x cube plus 1. This is a polynomial. What is the highest power of this polynomial? That is 15. Therefore, 15 is called degree of polynomial. The highest term of the or the highest exponent, sorry, not the term, the highest exponent of the polynomial is called the degree of the polynomial. The highest exponent of the polynomial is called degree of polynomial. Let's take an example. 3x power 4 plus 3x square plus 4x plus 1. Here what is the degree of polynomial? 4 is the degree of polynomial. In x plus 1, what is the degree of the polynomial? 1 is the degree of the polynomial. In phi, in constant polynomial, the degree of the polynomial is 0. That is x power 0. Therefore, 0 is the degree of the polynomial. This is a polynomial. What can we call it as? It is a binomial. We can call this as quadratic polynomial also. The polynomial which has degree 2 is called a quadratic polynomial. A polynomial which has degree 1, x plus 1, this is called linear polynomial. And a polynomial of degree 3 is called x power 3 plus x square plus x plus 1. It has a degree of 3, therefore this is called cubic polynomial. A polynomial with degree 2 is called quadratic, a polynomial with degree 1 is called linear, and the polynomial with degree 3 is called cubic polynomial. If we have polynomial of variable x, if we have a polynomial of variable x and of degree n, then the polynomial can be represented in the form of a power n minus 1 x power n minus, sorry, a power n x power n, a power n into x power n, plus the degree decreases in the next term. For that, let's take, that may be another constant or coefficient, a power n minus 1 x power n minus 1. Here the degree decreased by 1, plus a power n minus 2 x power n minus 2, plus so on, plus a2 x square plus a1 x1 plus a power 0. This is how we represent a polynomial. Consider a polynomial p of x is equal to x minus 1. Let's substitute 1 for x. P of 1 is equal to 1 minus 1, which is equal to 0. P of 1 is equal to 0. On substituting x is equal to 1, we got a value 0. Therefore, 1 is called 0 of the polynomial. Of the polynomial x minus 1. Or 1 is also called root of the polynomial x minus 1 is equal to 0. On substituting a value, the value of the polynomial becomes 0. The value is called root of the polynomial or 0 of the polynomial. I give you exercise problem. Substitute, they will give you an expression, polynomial equation x square plus x plus 1 at x is equal to 2. You have to substitute, solve the problem. What is the value of x at x is equal to 2? 2 square plus 2 plus 1. You have to substitute x is equal to 2 in the expression. So you get 2 into 2 is 4 plus 2 plus 1, which is 4 into 2 is 4 plus 2 is 6 plus 1 7. 7 is the value. Now you came to know what is 0 of the polynomial. On substituting x is equal to, or a value, if you write a polynomial of y, if you have y plus 2, on substituting which value you get the value as 0, then that value is called 0 of the polynomial, of that polynomial. Let's see here, let's substitute y is equal to minus 2 in the equation. So what do you get? Minus 2 plus 2, which is equal to 0. That is P of minus 2. Here minus 2 is called 0 of the polynomial y plus 2. Let's find out how do you calculate the 0 of the polynomial. Suppose they give you an expression 2x plus 1. They'll tell you to find out the 0 of the polynomial. You can do trial error hit and trial method. That is, first you can substitute value of x as 0, again 1 by 2 or 1 minus 1, or you can equate this to 0, this polynomial to 0. Now calculate the value of x. What is the value of x? 2x is equal to, if you send it to RHS, this becomes minus 1. X is equal to minus 1 by 2. Minus 1 by 2 is 0 of the polynomial 2x plus 1. In general, we can tell that if we have an polynomial ax plus b, then equate it to 0, then calculate x value, which is minus b by a. Then minus b by a is the 0 of the polynomial ax plus b. There is a fact that for a linear polynomial, always there is one 0 of the polynomial. You have observed, we have taken an example of x minus 1. Here we can notice that 1 is the only 0 of the polynomial. If you substitute any other value, then you don't get the value 0. But for a quadratic expression or for any other polynomial, you will have more than one zero of the polynomial. Let's take an example. P of x is equal to 2x square plus 2x. This is a polynomial. For this, let's substitute x is equal to 0. Then you will get, that is 2 into 0 plus 2 into 0, which is equal to 0. Now 0 is the 0 of the polynomial. Let's substitute other value. Consider a polynomial P of x is equal to x square minus 2x. Let's substitute 0 for this. As a value of x, P of 0 is equal to 0 minus 0, which is equal to 0. Let's substitute x is equal to 2 here. P of 2 is equal to 2 square minus 2 into 2, which is equal to 2 into 2 is 4 minus 2 into 2 is 4, which is equal to 0. Here we can see that for the polynomial there are two zeros of the polynomial. One is 0, another one is 2. But for the linear polynomial there is only one zero of the polynomial. Consider a number 15. Now divide it using 6. How many times it goes? 2 times. 3 is the remainder. How do you write this value? Right? 15 is equal to, that is dividend is equal to divisor. What is the divisor here? 6 into quotient. What is the quotient here? 2 plus the remainder. Remainder is 3. So you will get the value. 6 into 2 is 12. 12 plus 3 is 15. So we got the value. That is dividend is equal to divisor into quotient plus remainder. Consider 12 number and divide it using 6. The value got is 2 times. So this we can write it as 12 is equal to 6 into 2 plus 0. Here we can notice that the remainder value is less than that of the divisor. Then only we will stop the division. Here, if the value is greater than that of the divisor, then we could have divided it further. But the value of the remainder is less than the divisor, so we stop the division. Always the value of the remainder is less than the value of the divisor. Here the question is, can we divide a polynomial by another polynomial? Yes, we can. Let's see. Let's consider 2x cube plus x square plus x is a polynomial. We can divide it using a polynomial x. So if we divide it, what do we get? 2x cube by x plus x square by x plus x by x. So we got the values 2x square plus x plus 1. See, if we multiply this value with x, then we get the same value 2x cube plus x square plus x. We can tell that x and 2x square plus x plus 1 are factors of 2x cube plus x square plus. In previous case we had 15 is equal to 6 into 2 plus 3. here we can tell that these are factors of 15, or 15 is a multiple of 6, or 6 is a factor of 15. So here also we can tell x and 2x square plus x plus 1 are factors of 2x cube plus x square plus x, or 2x cube plus x square plus x is a multiple of x and 2x square plus x plus 1. Let's consider a polynomial and divide it using another polynomial. X square plus x minus 1. Let's divide this polynomial using x plus 1. Divide 3x square plus x minus 1 by x plus 1. We are dividing 3x square plus x minus 1 by x plus 1. Consider the first term of your dividend, 3x square, divided by x. So you will get 3x. Take 3x as a quotient. 3x into x is 3x square. 3x into 1 is 3x. This is minus 2x minus 1. Now consider first term here, that is minus 2x divided by x. So you got minus 2. Take minus 2 here in the quotient, multiply x plus 1 with minus 2, that is minus 2x minus 1. Here you got, minus 2 into 1 is minus 2. That is plus 2 minus 1 is 1. 1 is the remainder, 3x minus 2 is the quotient. So you can write this polynomial as 3x square plus x minus 1 is equal to, first is your divisor. What's your divisor? X plus 1 into the quotient, that is 3x minus 2. 3x minus 2 plus remainder is 1. So if you multiply x plus 1 with 3x minus 2 and if you add 1 to it, then you will get the value 3x square plus x minus 1. Remainder theorem. Let p of x be any polynomial of degree greater than or equal to 1 and let a be any real number. If p of x is divided by a linear polynomial x minus a, then the remainder is p of a. We have to prove if a polynomial of degree greater than or equal to 1 divided by a linear polynomial x minus a, then the remainder will be p of a. What they have given? They have given that p of x is divided by linear polynomial x minus a. P of x is a polynomial which is divided by p of x minus a. Therefore, this is the p of x is the dividend and x minus a is the divisor. Let us assume q of x be the quotient and r of x be the remainder. Then p of x is equal to, that is dividend is equal to divisor. What's the divisor here? X minus a. x minus a into quotient. What is the quotient here? Q of x. Let us assume q of x plus the remainder. What's the remainder here? R of x. We know that the degree of the remainder is less than the degree of the divisor. The remainder value should be less than the divisor value. The degree of the divisor is 1. Therefore, the degree of the remainder will be 0. Degree of remainder, that is R of x, is equal to 0. If the degree of a number or a polynomial is 0, then that is a constant polynomial. Let us assume R of x is equal to R. That is a constant. Let's substitute this in the equation. That is P of x is equal to x minus a into q of x plus, here we have R of x. We have proved that it is a constant. Substitute R here. Now, what is 0 of the polynomial x minus a? A. A is the 0 of the polynomial x minus a. Substitute that P of a is equal to a minus a into q of x plus r. So a minus a is 0, then the whole term will become 0. Then P of a is equal to r. That is, the remainder obtained is P of a. That's the proof. They give you a bigger polynomial, say a polynomial of degree 5 or degree 6, and they'll tell you to find out the remainder when it is divided by other polynomial. Say you have 2x power 4 plus 3x power 3 plus 4 minus 1. Sorry, 4x minus 1. Okay, when this polynomial is divided by x minus 1, then what is the remainder? Then you have to find the 0 of the polynomial x minus a. What is the 0 of the polynomial x minus 1? That is 1. 1 is the 0 of the polynomial x minus 1. Substitute 1 in the polynomial for x. It is 1 power 4 plus 3 into 1 power 3 plus 4 into 1 minus 1, which is equal to 2 plus 3 plus 4 minus 1, which is equal to 2 plus 3 is 5, 5 plus 4 is 9 minus 1, 8. 8 is the remainder when you divide this polynomial by this polynomial.